Hello everyone, this is Professor Munshi. I hope that my college students who are staying home because of this coronavirus pandemic, you all are doing well, and I am going to go over the CCNA 2 Chapter 1 from Cisco Networking Academy, NetAcad. So I'm sure every one of you have the access to this NetAcad courses. And for right now, as I always do in my class, I go over slide by slide from the Networking Academy and explain to you. Some of the slides should be easy, not much information in there. We're going to go fast. And some other slides where serious core concepts, important concepts are being discussed. We're going to give some time there. It will definitely help my students who would be otherwise seeing me in the college, in the classroom. And also, whoever is going to watch in the YouTube, you all can be benefited if you're doing CCNA. So let's get started. We're going to go slide by slide, chapter 1, 1.1, go from there. Some characteristics of network. Network, when we build a network, when we maintain a network, a network has many characteristics. Its topology means its diagram, its layout, its speed could be gigabit, could be fast Ethernet like 100 Mbps, could be 1 Gbps, which is the gigabit, or could be even 10 Gbps, or could be 40 Gbps fiber optics network. What kind of cost this network incurs? What kind of equipment we're going to have in here? Fiber modules, fast Ethernet, gigabit modules, what kind of cabling, whether it's wireless. So the cost is a big factor. Security is extremely big factor. Availability, how much this network we want to be available, how reliable it must be. Its scalability, whether we want to expand the network pretty soon for the need of our company, or we want to shrink sometimes that because the company will not need those equipment, those wings, those branches anymore. So scalability is how shrinkable and how expandable, primarily how expandable it is, that is scalability. And of course, reliability is very important. So we move on. These chapters are very, very basic. Why do we do routing? Well, here is the diagram. Let's understand it. It will help you understand the chapter slides. Here is a company that has a home office in a city. It may be in another city, it has a central office. Another city, it has a branch office. How are they connected? They are connected via WAN technology, wide area network. Why we are calling it WAN? Because look at this central location. The central location has many switches, multi-layer switches, and routers. There could be many routers. At the end, there's an edge router. This router helps this central location get connected to the rest of the world. Same way, in the branch office, we have many computers, many switches, wireless and wired switches, and at the end, it also has a gateway router, edge router, that connects it to the cloud, to the internet, or to the telephone companies such as AT&T or Verizon or whoever. Then they have a home office. Home office has a wireless router here that also helps you connect the home office to the cloud. So ultimately, all these three routers, they are connected to the internet. Therefore, these branch offices, these separate locations are able to connect with each other. That is a perfect example of a WAN. So this YOLO, this central location is a LAN, local area network. There's another YOLO, this area, it's a branch office, is another LAN, local area network. This other one, home office, is another LAN. These three LANs are connected via WAN, via these routers, and ultimately through telephone companies. So this LAN and WAN all work together. Now, why routing? Because this one PC, if you follow my mouse right here at the very edge, here in the central office, this PC wants to connect to, say, this other laptop in the branch office on my right. So this PC from here has to go through many switches. This is a multi-layer switch, maybe a router and switch. Then it goes through many more routers, ultimately this router right here. Then goes to the internet, comes back through this router. Now, when this data travels, how does it go? How does it know that it has to go through this router to this router to not, at the end, it's not going to end up being in the home office router. It will go to the branch office router. How does it know? Because of routing. Routing table tells a destination where it is located. With that IP address, what is the best path? What is the best way to go to that location? That is why routing is needed. Routing is needed when we are connecting to WAN, wide area network, and we have to go through one or more additional routers. That's when routing becomes necessary. So let's move on. Routers, the components of the router. Routers have CPU, routers have operating system, and different kinds of memory. There is a RAM, random access memory. There is a ROM, read-only memory, and NVRAM, that is non-volatile memory, and then the flash drive, flash memory. Now, if we look at the number 2 right here, click on the 2, beautifully explains that what is the RAM, random access memory, what does it hold in a router? It holds the running operating system. The iOS loads from the flash memory into the RAM, running configuration file, IP routing table, ARP tables, packet buffers. So anything that is currently running is loaded into the RAM, because RAM, we know, is a temporary memory. RAM does not hold anything permanently. When any program is up and running, that has been loaded to the RAM. Once you turn off the machine, turn off the router, turn off the computer, then RAM does not have anything anymore. RAM is blank, empty. That's why it is RAM. And all of these are going to load when, again, a computer or a router or a switch is operational, up and running. So it does not hold anything, again, permanently. Now read-only memory, ROM. ROM holds things permanently. ROM, let's see if I can make it bigger. Okay, here. On the other hand, ROM, read-only memory, that is non-volatile, meaning it will not forget. It is not going to forget. It is going to hold it permanently. In a router, what does ROM holds? ROM holds the boot up instruction. Okay. So in router, ROM holds the something called bootstrap, a small firmware, a short version of iOS that is stored in the read-only memory. So when you turn off the router, the ROM still has that bootstrap program. A limited edition of iOS is in there. Firmware is in there. Then you have NVRAM in the router, that is non-volatile memory. And the non-volatile memory, that will hold the startup configuration file. When you configure a router, you assign IP addresses to the interfaces, assign the host name, and all the configuration that you do to a router. That is, when we do it, we're doing it in the running configuration. And the running configuration is in the RAM memory. But then we know RAM memory is going to forget everything once we turn off the router. That's why we have this additional memory called NVRAM, non-volatile RAM. That's where we're going to save the configuration file. The running configuration will be saved into the NVRAM, non-volatile RAM, and then it's going to be called startup configuration. This startup configuration will be permanently staying in the NVRAM until we replace it. Then the flash memory is where the iOS, the actual operating system, Cisco iOS, is installed. So when we turn on the router, the operating system that is in the flash memory, that is going to start loading into the RAM for the running time. So let's go to the next slide. Next screen. Here is an interesting. It's a picture. It's nice to learn what we have, all the ports that are in the back of the router. Let's take a look at them. I have blown it so you can see it, magnified it. This is USB port right here. You can stick a USB flash drive in there. Let's do it in a very easy way. So if you have you want to save the configuration file or save anything from the router, this USB interface can help you. Or you can save something from the router to the flash drive, or from the flash drive to the router. Yes, this USB port is going to help you with that. Here you have 1, 2. If you follow my mouse, these two ports are the two interfaces that router is going to use to connect to network. So for example, in this case, these are gigabit interfaces probably. This looks like to me a 1841 router. And so this is a gigabit 00, gigabit 01, two interfaces. So one of the LAN is going to plug in here. From here, the entire LAN basically is going to connect with it. Another interface, gigabit 01, an entire LAN is going to connect to it. That LAN is going to have more switches, many computers, and so on. And now this one is an auxiliary port. Auxiliary port helps us connect to a router when we're not close to the router, when we're not physically located near the router. And it's a telephone kind of port. In the old days, we used to use the dial-up telephone connection to connect with this auxiliary port. If I am not near the router is in Dallas, I'm in New York, I want to connect to my router via telephone line, that's when this auxiliary port is used. What about this console port? Console port is I want to access the router, I want to configure the router, I want to get into the router, and I am physically 2 feet away from the router. Then I'm going to use a console cable, plug in here. The other end of the console cable is going to connect to my laptop or my desktop computer, so I can turn on the router and go inside the router, type in all the commands. So that's my console port. So both console and auxiliary are for accessing the router. Again, console is for local access, auxiliary is for remote access. There is another one, console via USB. It's another console via USB. Now this one, let's look at these ports right here. What is this EHWIC? EHWIC. That is Enhanced High-Speed WAN Interface Card. Okay, Enhanced High-Speed WAN Interface Card. This is a slot. There's nothing in there at the moment. You can actually literally take this metal piece. It's going to come out. If you actually pry it, you can actually open it, bend it, and pry it and open it. There would be a hole there. You insert the high-speed WAN interface card in there, and there's two more interface. Same thing right here. These are called double wide EHWIC slots. So they basically enhanced high-speed WAN interface card. Two more in here. These two slots right here, they are for flash cards. You can add flash memory into these slots. Okay, so that's in the back of your router. Okay, so now if somebody is wondering that what does this WAN interface card look like, I can show you. Let's go to the Google. Let's go to Google Images. I'm gonna type in EHWIC. Okay, and this is an example. This is what it looks like. In that slot, in that hole, you insert this port, this card. You're going to have 1, 2, 3, 4. In this case, 4 interfaces you're going to get in this case. Okay, there are some other ones will not have 4. Will have less than that. This has 2. This is WIC, WIC, WAN interface card. So once in the back of the router, you break this spot right here, you can insert that whole card in there. You're going to have some more ports. That's what it's for. Okay, let's go to the next slide. Okay, it's a basic example. Routers interconnect network. Easy, not much time to spend in this one. It simply shows an entire LAN, local area network, is connected to this router. On my left, another entire LAN, maybe another location. Say this is in Dallas right here, and it has a router at the end, is edge router. This location on my right, say this is in New York, this has a router, and in between this 2,000 miles or whatever, so this is going through this WAN connection, wide area network, meaning this router is connected to the internet, to the Verizon or AT&T or whoever. This router R1 also connected to some telephone company, and that's how they are connected. That's what the WAN connection is. So routers connect many networks together, many LANs together. Okay, the router connection, and look at it a little more complicated. The same one, similar one that we saw earlier. Okay, not much to spend time here. Let's go. Okay, routers choose best path. Why do we have routers? What is routing table for? What is a route? A route is the best path. A route is a path that, say, if you follow my mouse here, this computer wants to communicate all the way to this other computer at the far left. So it has to go through many switches, many routers. Ultimately, it's going to go all the way to here. What path to take? How to send this packet from this one part of the world to another part of the world? That calculation, that path is the route. The best path is the best route, and routers help us, help the networks, help the packets travel via the best path possible. Okay, there are different kind of mechanism that routers use, different kinds of mechanisms that routers use to calculate that best path. This slide is showing how does the router calculate the best path inside the processor, inside the memory. How does things work? Very simple. The three process. One is the process switching. This is the older kind, older technology. What it does, look at here. If you look at this picture, that's going to make sense. Let me make it magnified for you. What it's doing, every packet, the first packet is going through, router is taking it in to its processor in the control plane. Processor saying, okay, I found the best route. Okay, go this way, exit. Second packet comes this way, again goes through the processing. The processor CPU says, yeah, let me look at this package. What is the source? What is the destination? Okay, I know where to send. Okay, go. So each and every package like that is going to go through the processing. That's why it's going to be slow process. It's going to be slow process. We don't use that anymore in the modern routers. Okay, what is the another way? The second way. The second way is called fast switching. And to explain to you, a picture would help you. Look at this picture. That way I can explain to you easily. So look at the contrast. The first one, every packet went through the process switching. Every packet went through the processor. That's why it takes long time, slow. Second picture, look at the fast switching. What it's doing, the first packet went through the processor, and the router determined the best path, looked into the routing table, found a match. Now it knows where to send, how to send that package, and the packet went out. Good. Second packet, third packet, fourth, all those packets, they didn't have to go through the same process anymore. The router already knows for the same destination, I don't have to go through the processing anymore. I already have done the processing on the first packet. All these consecutive packets are going to the same place. So no need to go send them through the processor anymore. They go fast. Now look at the even faster method. That is called Cisco Express Forwarding, CEF. On that, this once you calculate this kind of path using the processor for the first packet, then on the second time, after some time, you are sending more packets again. This time, none of the packets are going to go through the processor anymore, because the router already learned this route, knows that this is the right match for this source and destination. Next time, after a few minutes, you send some more data. This time, not even one packet is going to go through the processor, because it will be kept in the cache memory. This whatever router has learned right now, it will be stored in the cache memory. So look at the picture number 3 and see what's happening here. First packet, second packet, all the packets, none of the packets have gone through the processor. Every one of them gone through straight directly to the exit interface. So it came, say it came through, the packets came through gigabit 00, went out via, say, serial 00 interface, because router knows that's the interface it should send out. And this time it did not have to go through the processor because router already knew it and kept that information in the cache memory. Okay, these are the 3 methods. Again, the 3 methods are process switching, where every packet go through the router's processor and read, try to find a match in the routing table to determine the best path. Second process would be the fast switching instead of process switching. Okay, fast switching. The fast switching is only the first packet which is going to go through the CPU processor to determine the best path in the routing table. And consecutive packets are not. Third method is the Cisco express forwarding. Whatever has already been learned, for those source and destination, packets will no longer go through the processing. It's going to go directly from the interface to interface, avoiding the processing altogether, because that information is in the cache memory. Okay, let's move on. Now, interesting, this activity, some of the activities I'm going to leave for you to do, and some others maybe I'm going to quickly do it for you. Okay, let's try to do this one. What it's saying right here, that we need to drag these ones to the appropriate box. Okay, NVRAM, non-volatile memory. What does it hold? Well, it holds the startup configuration. It holds permanently the saved configuration. So what is the startup right here? So the startup configuration goes to NVRAM. Good. What does the flash hold? The flash holds the operating system. So iOS, Internetworking Operating System, it's going to go to the flash. Good. Now move on. Running configuration. Well, running configuration should be in the RAM, random access memory, which does not hold permanently, only when it's running, only when it's operational, for temporary. ROM, read-only memory. You cannot erase it. You can only read from it. It's going to hold permanently. Nothing else can be written on it. What does it hold? It holds the diagnostics and boot instructions. Yes, the firmware, the bootstrap. So I put it in here. And then I go ahead and do the check. Yes, it says correct. Okay, good. So let's move on. Let's move on. How about the second one? This one, I'm going to leave it for you. You just drag and drop the right kind of ports. So let's move on to the next. Okay. Sample LAN and WAN connections. Connect to a network. As we have noticed, they are just repeating the same thing for us to understand that multiple LAN, multiple local area network, they are connected by routers. See, here's a router, here's a router, here's a router. Everywhere there's so many routers. So when you are sending an email from here to somebody in South Korea, you are going through many routers, many routers. And that one router knows which router next to send to for this packet to go to the final destination. And that's very important. Okay, that's why we're discussing this routing. Okay, 3 very important points that we need to recall. We have learned this in the first semester of the CCNA. Now we're in the second semester now, so you already know what is an IP address, what is a subnet mask, what is a default gateway. This information, every computer has it. The computer that I am using right now, my computer has it. Let's go and take a look at it. I go to CMD, command prompt. Okay, I'm going to run as an administrator. And in there, if I keep it big, bigger size font so you can see it better. Okay, now if I type ipconfig, CONFIG, ipconfig. You all have known this, you all have done it in the past many times in my class, but I'm still starting as if that we're beginning. Here is an IP address, 192.168.0.10. That's my IP address in this computer that I'm using right now. Its subnet mask is 255.255.255.0. That means a 24-bit subnet mask. We have explained this in the past. We can more explain in the future whenever necessary. Default gateway. Default gateway is 192.168.0.1. They have to come from the same subnet. So the default gateway on my router's IP is 192.168.0.1, and my computer's IP is 0.10. They belong to the same subnet. And here's my subnet mask. The subnet mask says that the last number, last octet in this IP has to be different on each device. So my computer has .10, my router has .1, they're in the same subnet. Okay. Now, this IP address can be assigned statically or dynamically, meaning I can go to each computer and type up its IP address like that. Manually, I can assign that. Okay, I have 5 computers. One computer .10, another computer .9, another computer .15, another computer .45, whatever I want to put. Put the last number as I wish. Now, or I could say that no, I have 40 computers, and I'm not going to go to each machine and type up its IP address. I'm going to keep it to auto-config. Okay, automatically. That's the dynamically learn. So a DHCP server, dynamic host configuration protocol, a DHCP server is going to automatically assign IP addresses to all my machines. Okay, so either statically or dynamically, I have to assign IPs. Automatically is dynamically, and manually is statically. Okay, that's what it's saying here. This computer here, its default gateway is its router. This computer right here, its default gateway is right here, this router's interface, 192.168.1.1. That is this router. This router is the gateway for this entire LAN. So this PC1 has the same gateway, PC2 has the same gateway, PC3 FTP server, all of them have the same gateway. They have different IP address. Its IP address is .110. Its IP address .111. Its IP address is .9. But their default gateway is this one. All of them, their default gateway is 192.168.1.1, because that's the router for all of them here. Okay, that's the default gateway. And of course, their subnet mask could be the same for everyone in the same subnet, same LAN. Next. Now, same thing. This is a router R1. Just to give you a quick understanding what they're talking about in here. How do you document? What is a topology? A topology means a diagram, how your network is. Physically, it is not that simple. Maybe this computer is in the 3rd floor. This computer is in the 1st floor. This computer is in another building, things like that. But when we draw a diagram, we draw a nice diagram just to explain how the network is connected. That is called this topology, okay? Logical topology. So now, and this is called the documentation, an addressing table. An addressing table that shows all the IP address, all the subnet mask. It's good to keep this documentation to help us. It helps us know what IP is assigned to what interface. For example, R1 right here. This is fast Ethernet 00. This router is showing here 2 interfaces. One interface connecting this one LAN, one whole network here. This other interface, serial 000, that interface is connecting between this router to this router, this another network right here, another separate LAN. WAN, this one, but separate network right here, separate segment of network. So that's what it shows in the table. Simple. Let's go on. Okay, enable an IP address. As I mentioned, IP address can be assigned statically or dynamically. Let's take a look at how I can do that in my own computer. Okay, if I go, I type here network, WORK, network. Okay, here is my network status. Okay, local area connection. Here's my Ethernet. I click on my Ethernet. Okay, and then it's better to go through the control panel and network. Another way to do it is right here, my network interface. Open the network and setting. This is an easy way to go. Let's see. Network properties. Keep on changing. Control panel. Control panel will be easier. Windows is changing the menu system all the time. And where is my network and sharing? Let's look for network and sharing. Right here, network and sharing center. That's how we go. That's the easier way to go. Never can find out whatever is in the Windows. Local area connection. Click on it. Once I clicked on it, let me make it bigger. Okay, so you can see better. So again, how I went to control panel first, then I went to network and sharing center in there. Then I see I have this local area network, this connection. So I click on it. Once I click on it, then I click on the properties of it. I click on the properties, and here I see, oh my lord, yeah, all these networking properties. Here is my IP address, an IPv6 address. Well, IPv4 we're talking about right now. So let's either I double click on it or I click on the properties. There, I see this window that I can set obtain IP address automatically. That's going to be a dynamic address. I don't have to manually write down my IP address. Automatically, my computer is going to get an IP address from my router, from my DHCP server. Or I could choose, click on here and say, no, I would like to manually type up an IP address. My IP address is 192.168, okay, .10.9, okay, things like that. And then subnet mask comes up and default gateway is going to be my router. I can type up. So that is static. As opposed to if I click on this one, that is dynamic, meaning automatic. So I'm sure you all know this already. Okay, so now let's go back to where I was. Here I am. So that's what it's saying here in your chapter, that IP address can be statically or dynamically assigned. Good. Let's move on. Device LEDs. In the back of the router, you have lights. If you look at the back side of the router, there's this green light right here. These lights mean something. Here's light right here. Here's light. So what it means, let's look at it. Look at this gigabit. Gigabit 01, that's the interface, and gigabit 00. These interfaces have two lights. One is S and one is L. L stands for link. S stands for speed. So with this S, this green light is going to be blink plus pause. Okay, blink plus pause. Sorry, one blink then pause. Then it's 10 Mbps. Two blink plus pause, 100 Mbps, and three blink plus pause, 1000 Mbps or Gbps. So how much it's blinking is, if we say blink blink, then pause, then it's 100 Mbps. Okay. L, that's for link. Whether a cable connection is linked here, the other end of the cable is also linked to another device. The link is up and running, then you're going to have green. Link is active. Okay. And if it is off, this light, that means link, physical link is not working. It is not linked to another device. Maybe that device has been turned off, things like that. Or it is not properly connected, or the cable is bad, things like that. So same way, the console cable has your EN light. Okay, this is the console. Console has the EN light. EN light is green, that means port is active. Off means port is inactive. So by LED, you will have to learn this and read a little bit. Okay, console access. We already know how to access a router. The router has the console port. In that console port, you plug in your console cable. Okay, just like this. Here is your console port, and here's your console cable. So you plug in your console cable. This one end of the console cable plugs in here. That's the RJ45 networking port. The other end, right, this big end of this cable, that plugs into the serial port of your computer. If your computer did not have a serial port, then you need an adapter like this. That's going to give you from the serial to USB. Then you can connect to the USB port, because many computers these days don't have a serial port anymore. Therefore, you only have the USB port. So you need this cable plus this little adapter right here. So the serial is going to plug into the serial port, and this other end is USB, then it's going to plug in here. Okay, or it could be the mini USB, the small tiny USB, either one. Okay, so let's move on. Enable IP on a switch. How do we enable IP on a switch? We know that a switch does not need IP for networking. Right here, this switch S1. S1 does not have an IP address for networking purposes. No, it does not. Switches do not read IP, do not understand IP. Switches do not read the packet. Switches do not do routing. Switch only understand MAC address, media access control, the physical address, the hardware address. We know that. Only router, they deal with IP address, and PC, all the end devices, they deal with IP address. So why are we talking about a switch and an IP address? Because switch needs one IP for itself, so that from a remote location I can access this switch. So I can telnet to it, or I can SSH to it. Okay, I can access the switch remotely by its IP address. For that purpose, a switch as a device itself needs an IP address. Yes, and that IP address is assigned to on a virtual interface called SVI, switch virtual interface. In this case, if you look at this picture more closely, I'm in the switch, I'm in the command prompt, in the config mode. I go to the interface VLAN 1. So VLAN, virtual LAN 1, that is not a physical interface. That is not a fast Ethernet or gigabit Ethernet or any kind of physical port. It's a virtual port. Then I assign the IP address on it, an IP address and a subnet mask. And I use this command, no shutdown, to activate the interface. And that's it. Then I do that in the interface mode, in the VLAN 1. Then I assign default gateway, the router's address. Router is the default gateway for the switch. I assign that in the global config mode, not on the interface mode. So here was interface mode, IF. In that mode, I assign the IP address. Then I exit from that interface mode and go to the global config mode. In the global config mode, I assign the default gateway. Okay, that's for the switch as a device, not for networking. Okay, and let's see what is in here. Well, they're asking you to type the command. Do your practice at home. No worries. Let's move on. Now here, activity. Document an addressing scheme. Okay, document an addressing scheme. So what we're going to do, this is a router R1, has interface fast Ethernet 00, serial 000, these two interfaces. And I see IP address is already assigned here. I'm going to give you just one example and then move on. Router 2, here is R2. R2 has this serial interface right here and fast Ethernet interface in here. I'm going to just assign IP to these two things so you understand what they're asking to do. This router, see this R1 serial interface and R2 serial interface, they have to be from the same network because they're connected together. Okay, so R1 serial interface has 10, 10, 10, 1. So 10, 10, 10, that kind of range should be on this one, on serial 00 on R2 also. So 10, 10, 10. Okay, so 10, 10, 10, 1 has been assigned to this one. So 10, 10, 10, what are the 10, 10, 10, 2? That could go right here, serial interface. Okay, so 10, 10, 10, 2 should be right here. That's the network segment 10, 10, 10. One here and two here. There you go. So these two are in the same network. These two routers interface. Now this interface right here has to be the same in 172.16.20. That kind of port should be here. 172.16.20. Basic router settings. We know these things we have done in the lab quite a bit, and when more lab comes, we're going to be typing these commands. We know how to go to the global config mode. Okay, how do I assign a host name right here? Let's look at excuse me, more closely. Host name. This is how we do. We're in the router, configure terminal 1 host name. Good, we know this. Let's go to the second one. Enable secret. Okay, class. That means I'm in the global config mode. I'm typing this command, enable secret. That means the secret password for the enable mode or the privileged executive mode will be class. Then I'm assigning console password. So I go to the line console 0, password Cisco. Then I use the login command. All my students who are in the first semester of Cisco, you all have done that many times for many labs, and we're going to have more labs coming in this chapter 2, semester 2. We're going to have them in the hands-on. We're going to type these commands. So I really don't want to spend time here. This is just a matter of learning all these commands. You all have done that, and again, we're going to do that today, tomorrow, more and more. All these commands will be more practiced in our labs. Okay, so let's move on and learn more in the chapter. Okay, configure an IPv4 router interface. Same, we're going to be practicing how to assign IP addresses to an interface. Move on that. Same way, IPv6 address. We know how to assign that. Now, what about this loopback? Okay, a loopback is not a real interface. Remember, on a router, we assign IP addresses to the interfaces. For example, this router right here, R1, it shows 3 interfaces here. It probably has more than 3, but 3 interfaces are showing here. One is gigabit 00, one is gigabit 01, and one is serial 000. So these 3 interfaces. So every one of this interface, every one of these ports is going to get an IP address. This one gets .1, 192.168.10.1. This one 192.168.11.1. This one 209.165. So different kind of range, but each interface gets an IP address. Okay. So gigabit 00, gigabit 01, serial 000. What is my loopback? What is this loopback thing? Loopback is not a physical interface. You don't find a loopback in the back of the router. It's a virtual interface. It's a made up software interface, logical interface. So all we do in the router, we just make up as many loopbacks as we want and assign IP addresses. They have other needs. They have other uses. That's why we use the loopback interfaces. They don't connect a LAN because they are not physical ports. So how do I assign a loopback interface and an IP address to it? I just type interface loopback 0. I could do interface loopback 1, 5, 10, whatever, as many loopbacks as I want. Then I put an IP address and a subnet mask, and I do exit. I'm done. Loopback would be always up. Okay. So notice that I did not assign no shutdown command in here because a loopback interface does not need no shutdown command. It's going to be always up. Okay. That's one of the reasons that we assign the loopback. So we can actually ping the loopback interface. It's going to be always up to see whether the router is functional. For example, one of the uses. Next, configuring IPv4 and IPv6 interfaces. Configuring, we're going to do that. We're going to do that in our practical in the lab. There's no need for us to spend time just to look at the commands. We'll be using them all the time in the labs. So let's move on. IPv6 interface settings, same thing. Okay, let's see what command history feature. Any of those commands, I'm skipping them. We'll do in the lab again. Okay, router functioning. Okay, now router switching function. That is something to discuss a little bit. Encapsulating and de-encapsulating packets. Let's take a look at this picture to understand what they're trying to say here. This PC1 is sending some data to PC2 in this case. So PC1, of course, from the application layer to presentation layer to session layer to transport layer to network layer to data link layer to physical layer. We understand that. That way, it goes, the data goes now travels through from the PC to the router. Then from router's other interface to this router. This other interface to this router. So it goes through many, many routers. At the end, it comes to the PC number 2, and it finally goes up to the application layer, and the user will be able to see that file, that application. Good. Now, in these routers, as the data was going from router to router, it only went through layer 1, 2, 3, 1, 2, 3, up and down, up and down. IP address, MAC address, MAC address, IP address, physical address. That's it. All it's kept on going to go from router to router. And once we go up in the layer, we do de-encapsulation. Once we go from the up to the down, as we're going down, we are doing encapsulation. For example, we already know layer 7, layer 6, and layer 5, the same color. Why? Because data here is called data. Data is still data. In the layer number 4, transport layer, that's where data becomes either a datagram or it becomes a for the Dhcp segment. I couldn't find the word. It becomes a segment. Okay, that's encapsulation. Data became segment in the layer 4. Layer 3 segment becomes packet. It's put into a bigger bag, becomes packet. Then encapsulating, putting into the capsule. Okay. Then layer 2, it becomes a frame. The packet into put into another bigger size bag. So more encapsulation. Okay. So this is the way when going up to down, being encapsulated. And when it's going from down to up, then being de-encapsulated. This frame is being opened, layer 2 frame is being opened and open to layer 3 packet. Okay. Then again, this packet is being put into frame. Again, it's going to the physical layer and traveling to the next. So that's how it's being encapsulated and de-encapsulated, and it keeps on going router to router. Let's move on. Okay, sending a packet. Okay, you can, whenever you are at home, just play with this. It's going to show you play this button. That's going to show how it's going from router to router. I don't have to explain much in here. Let's move on. Okay, forward to the next hop. Okay. Also, I'm not going to do much in here. So as just to know that from the PC goes to the router, to the router, to the router, to the PC. Each time its MAC address is going to change. So this PC cannot send directly to the other PC. Okay, it cannot. This PC has to send to this router. So this PC is going to use this router's MAC address, this interface's MAC address. So MAC address is going to keep on changing each time it goes from one device to another device. But the destination IP address remains PC2's IP address. That's how it knows eventually it has to go to that IP. But MAC address, again, is going to continue to change. Okay. So move on. Packet routing, the same thing being discussed. I'm not going to spend much time on here. Okay. You just watch how it goes. Okay. Just as an example here, let me discuss a little bit in here. Scenario: PC1 is sending data to PC2. All devices are ARP complete, meaning all devices know ARP means address resolution protocol, meaning it knows that if you give this router an IP address and say, hey, I gave you an IP address, do you know the MAC address of that device? Router says, yes, it's in my ARP table. I already know. I don't have to discover again. So all of the devices, all the switch and all the router, they have in their ARP cache the address resolution protocol, meaning they know each device's MAC and IP address. Okay. So now, PC1, destination MAC address. Its destination MAC, PC1 is trying to send to PC2, correct? But PC2 being in a far away network, many routers away, PC1 does not know the destination MAC address. Okay, so destination MAC address will be this router's MAC address right here, because PC1 has to send to this router first. That is its default gateway. What is the MAC address on these routers? This fast Ethernet 00. MAC address is 0C03. So that's going to be the destination. Instead of being destination here, first the MAC destination becomes this. So this 0C03, that's going to be the destination MAC address. How about the source MAC address? Source MAC address, its own MAC address is the source, because it is the one who's sending 0A10. So 0A10 right here. Okay, that way. And I want you to, let me just go ahead and do this one. And the source now in here, source IP and destination IP. Of course, source is itself. This is the guy who's sending 192.168.1.10. This. And what is the destination? Destination is not this R1. Destination is actually here. This PC is the destination. So I use the MAC address of this router, but I'm using the IP address of this ultimate main final destination. Okay, and that is 192.168.4.10. That's how it should be. Okay, that's how it should be. Let's check. Yes, all correct. See, so basically, for the MAC address, you do in your local network's main destination. That's why MAC address, the destination, you cannot go all at one hop right here. You cannot do that. So MAC address keep on changing from router to router, router to PC, things like that. So let's keep on going. Okay, I'm not gonna discuss here. Best path. When a PC trying to send some data to another PC, then sometimes it has multiple paths. Actually, most of the times, if you are sending to a very far away remote network, you do have many paths, way too many paths. You can go through so many different different internet routers to reach to another destination. But which one is the best path? That's what you calculate. Routers do calculation and find out what is the best path to take, so it does not take too long for data to travel. So you have this bandwidth, okay, and hop count. Both are important. Hop count means, for example, hop means router. From here, from PC1, for PC1, one way to go is this. To go to PC2, one way is from R1 to directly to R3 and then go to PC2. Another way to go would be R1 to R2, then to R3. Sometimes this is better. Why? Because this one between R1 and R3, only 56 kbps, very slow connection, like the dial-up 56K modem, that kind of connection. On between R1 and R2, you have a T1 line. That's 1.5 Mbps, megabits per second, way better. And then R2 to R3 also has T1 line. So maybe in this case, going this way is better. So routers keep those things into calculation, the bandwidth, okay, when calculating the best path. And there are many different routing protocols. Our routing information protocol, it only does hop counts. It does not consider the bandwidth, okay, the speed. It does not consider. And OSPF, Open Shortest Path First, that does calculate the bandwidth also. Okay, it keeps bandwidth into consideration. And then the EIGRP, Enhanced interior gateway routing protocol. It does the bandwidth and delay and load and reliability counts everything. So there are different routing protocols that you can use. Okay, once I hit the 10 o'clock, which I'm 4 minutes away, I'm gonna give a break. And after 4 o'clock, we're gonna come back and finish the rest of the chapter. So I don't go on for too long. I'm gonna give like say a 10 minutes break and then come back. So now let's move on. Load balancing, administrative distance. Sometimes this best path is calculated via routing protocols. Routers have routing protocols running on them. And those routing protocols such as this ISIS, OSPF, EIGRP, IGRP, BGP, RIP, all these are routing protocols. They have their administrative distance. Administrative distance means how reliable that route is. If IGRP says, I know a route and I'm telling you this is the best route, then router says, okay, what is your administrative distance? 100. Okay, I know who you are. You are IGRP. You are a protocol. And you are telling me a path. I know how reliable you are. Your point is 100. Another one, EIGRP, summary route. It says, no, not that path. Another path is better. So router says, okay, what is your point? Your score is 5. You are way better. So I take you. I take your words over this IGRP's word. Okay. So administrative distance means this scoring, meaning how reliable you are. The lower the value, the better you are. The better that value, more reliable that path is. Meaning, so look at here, connected route. If a router says that destination network is connected directly on my port, on my serial port, that network is connected. So I know how to go to that network. Its administrative distance is 0, meaning it's 100% reliable. Because the router says, I don't have to go to any other router. It's on me. It's connected to my own hand, my own port. So that kind of route, that line in the routing table has administrative distance of 0, meaning the most reliable. Then static route, its reliability is almost just right under it. Static route means you being a network administrator, you say that I am manually writing down a line in the routing table. I am adding a line manually. I'm a human being. I know exactly what I'm doing. So it is very reliable. Okay, a static route written by an administrator, that route also gets priority. Its distance is 1. Then you see other different protocols have different kind of distance. Okay, so you have to learn OSPF 110, RIP 120. These two are very much, and then this internal EIGRP 90. These three you must memorize. Okay, EIGRP you get 90, OSPF 110, RIP 120. These ones you have to memorize, and of course connected is 0 and static is 1. Okay. Anyway, I think that's how much I'm gonna go for right now, and we're gonna take a break. This is gonna be our part 1, and the part 2 of this chapter we're gonna come back and finish up the chapter, whatever it takes, another hour or whatever it takes. So I'll just let you all have a break for a few minutes, okay? And if you have any comments, you should be, if you are watching live, you should be able to make comments underneath in your YouTube. I guess they let you do the comment. My channel is brand new. This is my very first video, so I'm going to be learning. We all are going to learn together how to do things in YouTube, okay? So just have a good break. We'll see you back in a few minutes. Thank you. Let's see how to stop it.